Day 151 of doing a LeetCode problem every day until I get a job. All right, y'all. Welcome back. Welcome back to another day, another LeetCode problem. Hope y'all are well rested and ready for this problem that we have here today, y'all. We're just finishing up on a month of easy strings. After we do this, we're going to do a month of easy hash maps and easy dictionaries. And then after that, we're going to get started on the LeetCode 100, y'all. But before we get started on the LeetCode 100, I want to make sure that we already did the easy arrays. We're finishing up. This is the last easy string, and then we're going to do the easy hash map. So I feel like that'll give us a strong foundation to build off of as we start the LeetCode 100, y'all. It's all about the fundamentals. We can't forget the fundamentals, and that's why it's important to do these easy problems before we get started on the more difficult, medium, and hard problems, because we all are here trying to learn something. And if we just jump around before people are ready for it, or we don't have any background or fundamentals with dealing with those types of problems, then we're just going to make it harder for ourselves, y'all. So we just got to make sure we put the work in first, and we just get through these easy problems that we're doing now. We got one more month, and then we're going to get on to the medium problems and do some more medium and LeetCode 100 problems. Now, before we get started today, though, y'all, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we can help push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the Swift community to grow. And in order to do that, we have to share this Swift content out with as many people as we can find that will actually watch it and that are actually interested in learning about the Swift programming language. So y'all support is appreciated for that. And now let's get into the main attraction, the part that y'all all are here for, the question. And today we have question number 819, most common word. Difficulty levels easy. You already know we're going to keep the solution as simple and easy to understand as well, because we're all here trying to learn something. And if we don't understand the solution, then we probably didn't learn anything when we leave this video, and that is not what we want. But the first part of understanding the solution, y'all, is we have to understand the question and what the question is asking. So let's see what the question says. It says, given a string paragraph and a string array of banned words, banned, return the most frequent word that is not banned. It is guaranteed there's at least one word that is not banned, and that answer is unique. The words in paragraph are case sensitive, and the answer should be returned in lowercase. So let's see what they mean by that. Let's look at the example 1. Example 1, we have input paragraph equals a string. Bob hit a ball. The hit ball flew far after it was hit. Band equals hit. Excuse me, y'all. Band equals hit, and the output is ball. So let's see how they got that. So the explanation says hit occurs 3 times, but it is a banned word. Ball occurs twice and no other word does, so it is the most frequent non-banned word in the paragraph. Note that words in the paragraph are not case sensitive, that punctuation is ignored even if adjacent to words such as ball, and that hit isn't the answer even though it occurs more because it is banned. So let's break that down. Let's look over this again so we can really look and see what it is that they're asking us to do, because it can get confusing. So we have hit right here, we have hit right here, and we have hit right here. If you notice, hit occurs 3 times, right? Boom. So in actuality, you would think, oh, that's the most common word, hit. However, hit is in the banned list, so we can't use hit in our output, right? We have to skip past hit. Even though it's the most common, it's in the banned list, so it doesn't count. We can't worry about it. So after hit comes ball. We have ball right here, and we have ball right here, right? So that is, ball appears twice. So that's the next most common word, and it's not in the banned list, so we can use that. That's why the output is ball. However, we have to see, it says right here, the words in paragraph are case sensitive, and the answer should be returned in lowercase. Even though right here it says, note that the words in paragraph are not case sensitive, I don't know why they're contradicting themselves like that. I don't know what that's supposed to mean. However, all I know is This what we're gonna worry about right here. The answer should be returned in lowercase. So if you look at paragraph, we have ball right here in lowercase. Then we have ball right here, and it's all uppercase. But the answer has to be lowercase, so we return ball in lowercase. Then it says, right here it says, punctuation is ignored even if it is adjacent to words such as ball. So that's important as well because ball right here has a comma or punctuation after it, right? So that lets us know that we cannot split the words up by white space. Normally we might just split the words up with a blank string or something, put a space in between the two quotation marks or something. That's not going to work here because there might be a punctuation like this. So this does not count as white space. So we don't want to include it in the output, right? So we can't just take all this and put it in the output. We just want this in the output. So we have to be careful and get rid of the punctuation as well and just return the ball by not splitting up by just white space alone. And then that's why the output is ball. So now let's look at example 2. Example 2 is a little shorter. It's a paragraph. Input is paragraph equals a string A period. Band is a blank array. The output is A. So this is kind of similar because you notice the paragraph is A period, but the output is just A without the punctuation. So we have to remember to get rid of the punctuation when we create our output or when we return our output because we just want the letters or the characters. We don't want the punctuation. So we can just, once again, we can't split it up just by white space or a string of space. We have to find another way. So now that we understand what the question is asking, let's get into the fun part, the part that keeps us motivated, the part that keeps us happy and joyful in the morning, the actual code, y'all. So let's get into it. The code's not that difficult either, y'all. So let's get into it. First thing we're going to do is we are going to declare a constant called word or words. We're going to set that equal to paragraph dot lowercase. So we're going to convert them all into lowercase off the back. We're going to convert the whole paragraph into lowercase off the back. Then we're going to say dot split, open up the brackets, exclamation point, $0. So what this $0 does is going to represent every word in paragraph. Each word in paragraph, this $0 is going to represent it, right? But right now, we're trying to split it up, right? Or we're trying to split it up into words, right? So we're going to split it up by saying dot is letter. And this is going to allow, or not letter, that because this is the exclamation point. So it's going to split it up if it's not a letter, right? So as soon as it sees something that's not a letter, it knows to split it up, including white space. So boom, it sees right here, this white space, it knows that's not a letter. So it could split these two words apart. Right here, same thing. White space, it's not a letter. So it knows these are two separate words right here. Same thing right here. White space. This white space. So now it knows these are two separate words because this white space is not a letter. And that's important for when we get to right here, the punctuations and commas. It knows that this is not a letter. So it knows to stop right there. We just want this right. It knows to stop right here because it's going to get right here and it's not a letter. This in white space is not a letter as well. So it's going to split ball and the up like this. Everything that's not a letter is going to get rid of. And that's how we're going to get rid of the punctuation with this part right here. Exclamation point, $0 is letter. Or it's saying not a letter is what it's saying. So then after we do that, we're going to say declare a variable called frequency. We're going to set that equal to a dictionary of strings, integers. Come outside of that, and we are going to put the parentheses. And that's why I like this solution today, y'all, because like I said, tomorrow we're going to stop doing these easy strings and we're going to start doing easy hash maps and dictionaries. And what better way to transition into hash maps and dictionaries by other than finishing our last string problem that we can solve with the hash map and dictionary. You know what I'm saying? So that's why I feel like this is a good solution. It's a good transition into what we're about to start tomorrow with hash maps and dictionaries. So then we're going to come down here. We're going to say for word in words where we're going to put an exclamation point band. Then we're going to say dot contains. Then we're going to open up the string. Open up the parentheses, and we're going to say string. Open up more parentheses, and we're going to say word, right? So what this is going to do is going to say for word and words where this exclamation point is going to say band does not contain that word. So if band contains that word, then we're just not going to use that word at all. But where band does not contain that word, that's what the exclamation point does. We're going to keep going, and we are going to say, open up the brackets, and we're going to say frequency, open up the square brackets, string, open up the parentheses, word. We're going to come outside those parentheses, but inside the square brackets, we're going to say comma default colon 0. Come outside the square brackets, and we'll say plus equals 1. So what this is going to do is it's going to keep the frequency or the amount of times that we see this word, right? We're going to start the count with 0. Excuse me. But every time we see this word, we're going to add plus 1 to this 0, right? So this 0, we're going to start at 0, but we're going to add plus 1 every time that we see this word, and we're going to keep track of each word and how many times it has been seen. Then we're going to come down here, and we're going to say let filtered with an ED at the end, say equal frequency dot sorted. We'll open up the brackets. We're going to say $0. Once again, this is going to represent each dictionary, each frequency dictionary that we're working with. Remember, each word is going to have its own dictionary, or it's going to have its own word and count. So this is going to go through each word and count that we're dealing with. So we're going to say $0 dot value is greater than $1 dot value. So if this $0 equals every word or every frequency, this $1 is going to equal. It's kind of similar to like if $0 was 4I in word, $1 would be like 4J and I plus 1 in word. You know what I'm saying? It's similar to that. So then we're going to come over here, and we're going to say dot map, open up the brackets, $0 once again, because we want to loop through everything, every word and count that we're working with, every frequency dictionary that we're working with, and we just want the key though. We want the key. So every dictionary has a value. Oh, excuse me, this is the value right here. Every dictionary has a value, and every dictionary has a key, right? So the value right here is going to represent this, the number of times that we've seen it. So we're going to sort it by how many times we've seen it. However, we're going to return the key, because remember, we want to return the word. We don't want to return the count, right? So this key is going to give us the word. It's going to help us to return the word and not the count, because remember, this is the key, the word is the key, and the integer is the value. We just want to return the key, or we just want to return the word, which is the key in this case. And then we're gonna say return filtered. Excuse me, it should be ed. Open up the square bracket 0. So the first index of all of the frequencies that we've seen, the first one, that's the one we want. So let's clean this up a little bit. Let's clean it up. Let's run it. Let's run and see if it runs. Let's see. Okay. So let's submit it. Make sure it's still going strong. You know how LeetCode does. Always run it before you submit it. And there it is, y'all. 10 milliseconds beats 78.79% of users with Swift, y'all. Not too bad at all. And that concludes our LeetCode problem for the day. I hope y'all learned something, and I hope to see y'all tomorrow for another day, another LeetCode.